Welcome to EDU World Space.
In this problem, we're given that there is a right triangle that is submerged in water, and we're asked to approximate the force acting on one side of this triangle. We know that force is equal to pressure times area. We can write this one as rho times g times d, where d is depth, multiplied by area. And we can also write this one as specific weight times depth times area. We know what specific weight is, that is 62.5 pounds per feet cubed for water. So this part is known. We need to determine depth and the area. Let's start from the area. Area is the area of this thin strip, this shaded region, integrated along this edge. So we would then, if we zoom in, we need to approximate the area of this. And if we assume that this is an infinitesimal thickness, dx, the area would be then dx times whatever this length L is. Now we need to determine this length. In order to do that, we first need to find the equation of this line. So let's assume that we have an origin located right at this point. So this is our 0, 0 point. So this point would be, or this level would be x equals 2, and this level would be x equals 7. This would be y equals 0, and this then would be y equals 10. So in order for that line, the coordinates of that line would be 2, 0, and 7, 10. We know that the equation of the line will be of the form y minus y naught is slope times x minus x naught. And slope using this given points can be found as 10 minus 0 divided by 7 minus 2. So difference between y's divided by difference between x's, that is 10 over 5. So the slope is 2. We could use either of these points. Let's use this first point. So let's write this one as y minus 0 is equal to 2 times x minus 2. So y is then equal to 2x minus 4. If that is the case, we can then write this area as, since this is y in terms of x is 2x minus 4, it means that length is 2x minus 4. So the area would then be 2x minus 4 multiplied by dx. And this would be actually this infinitesimal area of this thin strip. So in order to find the total area, we would need to integrate it, or we would need to sum those areas up. Now, the next thing to determine is the depth. So d, let's say that we're measuring this from the surface, and since these are x levels, let's say that depth is x. That also changes depending on where our thin strip is at. So we can then write the force, or infinitesimal force acting on this infinitesimal strip, as 62.5, which is delta, multiplied by x times 2x minus 4 dx. Now we would need to integrate it. We can also write this one as a Riemann sum. So the total force would be limit as n goes to infinity, summation of those all thin strips from 1 to n, 62.5 multiplied by x times 2x minus 4 dx, or we can write this one as delta x, and we can actually convert that into an integral, where the limits of the integral will be the limits of the x. We said that x changes between 2 and 7 for this given right triangle, so it will be from 2 to 7. 62.5 times x times 2x minus 4 dx. That is 62.5 is a constant, 2 to 7, 2x squared minus 4x dx. That will be 62.5 is again just a constant. We had 2x cubed over 3 minus 2x squared. We need to evaluate this at 2 and 7. If we do so, we find that the force acting on the sides of this right triangle is 8,333.33 pounds.